My name is Johnston, and I'm a physician trained in aerospace and internal medicine. I'm excited about doing this interview and educating folks on the use of light to combat circadian dysynchrony and jet lag and shift work, and how we use that with one of the most important populations that I get to work with, and that's our astronauts. The weightless environment of outer space is not user-friendly for sleeping. One of our biggest problems was fatigue and sleep, because they couldn't sleep. You're getting a sunrise and sunset every 45 minutes on the space station. The other thing is you're floating 24 hours a day. So your back actually loses its lordotic curve. It straightens out. So until they get used to that over a matter of weeks up in space, they have back pain. So that for the first few days, they've got back pain. They may have a little sickness. They have high carbon dioxide, and they have a ton of things to get done. And it's like the ultimate shift worker having to do the ultimate job. It's a very similar model to special forces in the military. And so the astronauts themselves were having trouble with sleep. And they asked our medical group to bring in a panel of experts. So we did. We developed a group of sleep experts worldwide. We worked with Steve Lockley and Chuck Seisler and Beth Clairman out of Harvard. We worked with Fred Maxick from Healthe Sciences, and worked as a team to see what we could do practically to put a program together that would help all of us, whether we're at mission control or whether we're astronauts traveling. We brought together a team to help use light and dark cycles, to use light at the appropriate timing and darkness at the appropriate timing, to help shift our people 3 to 5 times faster than you normally shift when you're just flying on your own. It really comes down to 3 components. First of all, how long has a person been working? Once you've been working like 18 hours straight, you basically have a blood alcohol level of 0.05. Your cognitive function is decreased. That's what we're constantly trying to mitigate. And what we deal with our astronauts, we're trying to make sure that they're well rested using light, using blue light to alert them and shift them, avoiding light before you go to sleep, getting away from your LED screens, getting away from your computers. That's what's really important. And so what we've learned is the proper use of LED lights. And that's what we've done with our spacecraft vehicles. We've been able to outfit them with new LED technology and be able to give the astronauts a normal day-night cycle, so they can have a normal day-night circadian rhythm, so that when you need to see blue light to be alert, you can see it. When you need to just have normal background light, you can have it. And when you need to avoid blue light, but you need to read and be able to function and get around, then you can dial in that kind of proper lighting so that you can have a normal circadian rhythm. So everything we're learning about what the astronauts, how well they breathe, how strong they are, what their diet is, everything that can help them sleep is going to help them live longer, and it's going to be a spin-off that we can impart to our folks here on the ground, to our shift workers, to all of the executives that travel the world and who have to show up the next morning and give PowerPoint presentations and perform, that they can shift well, that they are going to be at the top of their game, and ultimately that they're going to be able to sleep more, and it's going to affect their longevity.